in Compose, if you know what you're doing, you can pretty much forget about using plain view models for holding state and handling state, and you can also forget about flows for state handling. So all the flows being collected in a view model, state flows for exposing the state and then collecting state on the UI side, you can pretty much forget about it. And today we will see how to do that with Circuit, and you can take most of these and just use them elsewhere in a pure Compose app, and it will work just fine. What we will cover are all different ways of collecting and handling state inside that Circuit provides, what are the benefits and how to use each one of those. We have a slight outlier here, which is the most recent addition to Compose, being a retain API that is they did not build it with that in mind, but that is the closest equivalent to rememberRetained, but we will see how they differ. We will also cover how to handle state purely in Compose, how to collect flows, and how to combine them if you need to bridge pre-existing logic that you have, for example, inside of a repository, how to bridge that in a pure Compose world. And about combining flows, this is my biggest hurdle with flows. Flows are very nice API, but when you have to combine them, things get messy pretty hard. At one point I was working on a project, and we inherited a view model that did 4 combines. It combined 3 times just to get flows ready for the 4th final combine to expose the actual state. So it can get pretty messy, and we will compare the combining of flows to handling that inside of a Compose. To be able to showcase what we are doing, I just changed our app a bit from the last video. So this one now has both increment, decrement, and go to the other screen that would just represent what we the count that we had. And you can already see one problem that we will cover, that count is not being retained. If we go to 10, go to another screen, 10 is being passed correctly, but when we go back, it's a 0. But we'll come to that. So this is the change. These are the changes that I've made, so I can showcase all the different approaches to state holding and state handling. From the code standpoint, the only thing that changed is the addition of assisted navigator injection with the Metro. This is a bit more involved than, for example, with the Kotlin inject. With Kotlin inject, you don't have to do to create this factory, but here it is. And Navigator API is so simple, I'm not even going to cover it. It is just go to, pop, peek, replace. It's very simple, and we just, go to other screen. If we see what the other screen is, very simply put, again, we have navigator, we have the screen. I already explained how we are passing data using screen. This screen now it is a data class. Our first initial counter screen is a data object. This one is a data class, and we have count that we are passing, and the presenter is getting that screen to be able to get count that we passed. And the only thing that this screen is doing is presenting that, and we have the event to go back. And as I said, very a simple navigation API. These are not even suspended. If you take a look at the gutter icons, it's not even a suspend function, and just pops the current screen. So these are the changes that are made since last video. And I want to correct myself on one thing. In the initial video, I said that this will be exposed as a flow of state or a state flow. I don't remember what exactly I said. That's clearly not true, because as you can see, this is just plain state. What I meant to say is that this is the equivalent of having state flow inside of a view model, and this one is much simpler, but this will not be exposed as flow state. As you can see, this is a plain compose function, and it gets all the benefits of being a composable function. It will be treated as every other composable function. It will get a composer, and it will get changed parameters when it goes through the whole, compiler phase. But yeah, just to correct that, it will not be flow. It is the state as we defined it, and it will be exposed as such. There are ways that you can turn compose state changes into flows with molecule, but that's the other topic. When we are dealing with state, especially on Android, we need to take care about multiple things. For example, screen rotations, configuration changes of any kind, and there are a lot. Process deaths, etc. And the first one that we will be focusing on is screen rotation. As you can see, right now it handles that, but only because I have these flags defined inside of my manifest file. This is for the compose first apps, as you can see here. Adam Powell was saying that since 2021. So basically, if you are doing the compose first app, autocomplete every known configuration change into the config changes attribute of your activity tag in the manifest. That is what I just shown, because compose will react and update gradually from any of them anyway, so you don't need activity recreation at all. So we can basically forget about configuration changes for the compose first apps, but maybe you are in the app that's not compose first and not purely compose. In that case, your activity manifest will look like this. And now if we run the app with changed flags, configuration changed flag, we will see a different behavior. Increment, rotate, it goes to 0. We can again rotate, 0. We go to another screen, we come back, 0. That is because we're using pure remember here. Remember will remember across recompositions, and because we don't have key, until something changes like screen rotation, it will have the state that we assign. But if we want it to be, if we want state to be retained when we rotate the screen and when we go to another screen and come back, there is the ready to use rememberRetained API. That this is provided by Slack, and if you dive deep into this, you will see that it hooks in the same APIs as ViewModel does. And if you take a look into the rememberRetained, you will see that it uses local saveable state registry and all mechanisms that are also used by ViewModel. So it uses the same mechanism. And for deeper dive into how that all of that works, I have a very deep dive into all of that, and I will put a card up here and you can take a look. But just this simple change, so rememberRetained provided by Circuit, will give us the ability to to retain state. We go back, we go forward, we go back, we navigate, and we have our state saved. On the beginning of the video, I mentioned that there is also a retain API, that this is purely compose and it's not hooked up with navigation. And if we are using retain, you can see that it retains on screen rotations, but when we go to another screen and go back, it is 0. That is because rememberRetained, it also uses circuits navigate. It is wired into navigatable circuit content registry that for every navigation record or for every screen, and it is saved until that store that I just showed you is completely removed. So when the screen is completely removed from composition, then it will forget the state. But retain works the other way around. It uses retained values store, and it's not wired with navigatable circuit content in order to work across different when navigating across different screens. So that is the difference with that. Another thing that we need to care about are process deaths. To simulate that, I will just put the app in the background, and let's have some count. So here we come back, it's 5, but now I will simulate the process death. So process died, we are recreating, and we are coming to 0. For this, we are using plain compose rememberSaveable that will handle this. And let's see. So the rememberRetained was circuits implementation of for retaining state. rememberSaveable, same as remember, comes from compose. So you see how you can use those elsewhere and not just with circuit. And now again we come back, we navigate, we go back, it's there, and then we kill the process, we go back, and we still have our count retained. There is another one, a bit of a niche use one. This one is provided by circuit, and it's a bridge between rememberRetained and rememberSaveable, and it's rememberRetainedSaveable, and it handles both use cases that I showed you for retained and for Saveable. And if we run this right now, you will see that it retains across navigations to another screen. When we background the app, simulate process death, we go back, it's still, our count is still there. Why I say that it is a bit of a niche use, it is because it also, if you can see, it takes a saver for rememberSaveable to save state. And how that works, let's say that we have some test object, we have count, and we have some map. I will use a map because it is not automatically being saved. Compose that doesn't have the ability to automatically save it with a saver. We need to provide a saver for it. And if we do this, for example, by rememberRetainedSaveable, this will do, it will be the same as for just rememberSaveable, what I'm going to show you. So it is a test object, we have count, let's put it at 0, and have empty map. If we run this right now, it will crash, yes. Why it is crashing. Let's see what it says. And again, if I have a video on this explaining how this works in a great detail. And this rememberSaveable and by proxy rememberRetainedSaveable fails fast. It will not wait until you actually try to save the object to crash. It will crash when you are trying to create this. It first checks if the object can be saved, and as I mentioned, map cannot be automatically saved. It needs a provided saver, and map cannot be saved using the current save state registry. The default implementation only support types which can be stored inside of a bundle. And this is where the niche thing comes into play, and we can, for example, have this as an empty map, doesn't matter. And we will now provide a custom saver. And this is where the niche part comes into play. As you saw, map cannot be saved, but maybe we want just to save count, because that's usually what you want to do. Let's say that we have a screen with a query and the list of objects that we got using that query from the API. You want to retain everything across the, when navigating between different screens. You want to be able to go into details for the object, let's say post, then go back and then go back to a list of posts and not do a request again, etc. But when it comes to process stats, you don't want to save 100 posts. You just want to save the minimal amount of data that will help you to get back to the state where user was before process was killed. And in the query and posts example, that would be just query. And in that case, you would want to save only query. And when the process is being recreated and restored, you have the query, then you do the API call for that. You get back a list of posts, and we have that use case here, let's say, and we want to define saver, and we have save and restore. This is again just pure Kotlin and compose thing. This is not circuits implementation. And then we want our test object with count, for example, let's say it, but I will provide it, and then we will say it.count. This is showing an error because it needs to be opted in, but right now test object will be saving only count and restoring only that saved count. The empty map, the map we don't care about when coming from process that, and this is nice way to combine handling process stats and navigating across different screens. In a view model, you would need to save the for example, count in a savable state holder, and the map or the list would be in a view model itself, and then you will need to somehow combine that. And you see that here with compose and circuit, we have a really nice API that we can work with. And just to showcase that it works, now it's not crashing. As you can see, it works perfectly fine. We are not using it right now, but again, it's not crashing, so it will save and it will restore correctly. And just to show you why our screens are being retained across process deaths. Let's just go here, and then we are on the other screen. We background it, we kill it, kill the process, we go back, we are on other screen instead of initial screen. That is because we are using rememberSaveableBackStack from circuit, and again it hooks into the same savable thing, and navigatable circuit content knows how to it wires everything up, and it knows how to save and restore. And now the other part of the video, how to bridge two worlds, how to bridge flows and compose. You already know this if you worked with compose and view models, because you had to expose. You don't have to, but it's the most followed pattern to expose state flow, and you were collecting it. And let's just define one here. Like so, and we want to collect it. There is one that you are already probably familiar with, and it is flow collect as state. We need to give it the initial state, let's say 0. This is how you would collect state from the state flow for a view model. And again, we have the retained state variant that will have all the same benefits that I showed before for remember retained. The other approach that you may not have used a bunch is a produce state. Again, we have something, some initial state, and then we would do flow collect, just a pure collect, and then value is equal to it, the collected state. When you would use one over the another, depends on your use case. Collected state is very easy one to use, and when you don't need, for example, to do a retry, when you don't have things changing under you, and produce state, like everything else state related, it takes keys. So you can have this, we can have count. So we can, whenever count changes, we want to collect state again. This count can be user ID. This can be, for example, retry count. This can be retry count, and we would increment this retry count on every failure, and then when we increment, it would change, and this will retrigger in case of failures, etc. And when you would actually use that, if you have just plain flow that you want to collect, then you would be doing either collect as state or collect as retained state. Either one of those works. You can also do shenanigans like this. You can have remember with count or retry count, so it will recreate a flow every time. It will cancel listening to it every time that this changes, the key changes, and then you can collect it. This is safe to do, because as you saw, remember doesn't translate when you go to another screen, when you rotate the screens, etc. But what is not safe to do is to do remember retained. This is not safe to do, because now you will hold onto this flow when you are on the other screen, and it will not be, the collecting of this flow will not be cancelled, and you may have, depending on how involved the creation of this flow and emission of of values is, but you will certainly leak resources, you may have performance issues, and this is just a leak that you don't want to have. You want to scope things properly. And again, this is the safer variant, but when you are doing this, you might as well do a produce state. Hello, future me here. I forgot to show you the combine example. Now for this one, let's just take one really simple one, and to help you visualize the example, let's take a look at this screen. So we have a list of tasks for the day. The label mentioned here is the label that I'm now entering and creating task for, and you can go backwards, forwards with your dates, and the tasks are loaded for each day, and there is an error message for deleting tasks, etc. And just for this one, you can see that we have 3 different mutable state flows that we have. We have to observe tasks, and then we have the final state. Again, it barely fits on the full screen here, and the combine, it's not bad as it can be, but again, you see that it adds a bit more verbosity and a bit more overhead that you need in order to understand it a bit more. This is a very simple example, but again, this is just a state that both view model and presenter are using, and that's it for the presenter. We don't have anything weird to do. We have just 3 normal fields that are not flows, so we don't need to combine them. We use them to return the state, and the logic here is the same as the above, and you can see that the whole presenter and even more fits on the screen. It's easier to understand, no overhead, and this is just a simple example, and it's much cleaner. It's not that big of a deal, but if it helps, then it's good. Here we see that we're using collect the state for the account. If we want to lock paid features behind a paywall, for example, etc. This is just a sample code, but there you go. That's it for this one. We saw how we can manage state with circuit, with presenters, and I hope that you see how you can take this out of the context of circuit and use those principles elsewhere, and you can even do that in a view model, although it's not that conventional thing to do. And see you in the next one when we are talking about testing.